Welcome back to the deep dive. For, I don't know, the last couple of years, we've been in this world where AI models could, write a pretty good poem
Or debug a
or
script.
debug a Python script, right?
Yeah.
But if you asked it to do something real, like log into a corporate system and restart a server, the whole thing it would fall apart. It was a game of chance.
It was completely stochastic.
Yeah.
Yeah, you were essentially rolling the dice on whether the model would hallucinate or just forget a step.
Exactly. But looking at the AWS release log for this week, we're talking February 2nd to the 9th, 2026, the whole tone has just shifted. It's not flashy chat features. It's plumbing. It's updates that let an AI manage state, format data perfectly every time, and operate inside these legally sealed clouds.
If I had to put one word on this week, it's industrialization. We are moving past the lab experiment. The updates from Claude Opus 4.6 to the new AgentCore stuff, it's all about reliability.
It's taking that probability engine,
Yeah.
forcing it to act like deterministic software?
That's a perfect way to put it, forcing it to be predictable.
Okay, so here's our roadmap. We're going to start with the new model, Claude Opus 4.6, and a feature they're calling structured outputs, which sounds like a huge deal.
Oh, it is.
Then we'll get into the AgentCore updates, specifically how they finally solve that login loop problem.
Which is a massive headache for anyone trying to build a real agent.
We'll also look at the new European sovereign cloud, which is a lot more than just a new data center.
Yeah.
And then we'll wrap with 3 case studies, BGL, Clarus Care, and Associa, that show how this is all being used right now.
It's a heavy engineering week. Let's get into it.
Okay, let's start with the brain. February 5th, Anthropic's Claude Opus 4.6 goes live on Amazon Bedrock. They're calling it their most intelligent model, but the phrase that caught my eye was optimized for long horizon tasks.
That phrasing is very deliberate. Long horizon is an AI term for the ability to maintain a coherent plan over many, many steps. Think about an agent refactoring a whole software library.
It's not one step, it's 50.
Or 500. And the math is brutal. If your model is 99% accurate on each step, by step 50, your chance of success is dropped to, what, 60%?
That's not good enough for production.
Not even close. So Opus 4.6 is designed to get that per-step error rate incredibly low so the whole workflow doesn't just collapse. It has a 200,000 token context window out of the box with a 1 million token preview.
1 million tokens isn't latency the killer there?
It is, which is why this isn't for a chatbot. This is for what we call slow thinking. You load an entire legacy system's documentation in, give it a complex migration plan, and you let it run for 10 minutes.
It's a batch job, not a conversation.
Right, it's a professional work engine.
But even the smartest engine is useless if you can't parse what it sends back. So that brings us to the February 4th update. Structured outputs on Bedrock. This feels like a feature that makes engineers weep with joy.
It solves the retry loop. Until now, if you wanted JSON with, say, a customer ID and a balance, you had to ask the model nicely.
And pray it didn't add, here's the JSON you requested, or...
Or miss a closing bracket, which crashes your whole downstream parser.
Right.
So structured outputs uses what's called constrained decoding. As the model generates tokens, the system itself masks out any token that would violate the JSON schema you gave it.
So wait, you're saying the model isn't deciding to follow the rules, it is physically unable to break them?
Precisely. It's mathematically prevented from writing anything other than valid JSON that fits your schema. It's deterministic.
Wow.
And there's a key performance detail here. Bedrock now caches the compiled grammar from that schema for 24 hours.
Wait, not the answer, the
Yeah.
rules.
Compiling a complex schema into that token mask takes a bit of compute. So if you're processing 50,000 documents a day with the same schema, Bedrock does that compilation once, caches it, and every subsequent call is faster.
That is a massive optimization.
Okay.
Let's move from the model to the agent itself. Segment B, the plumbing. February 6th, AWS updates AgentCore, specifically its browser tool.
Right. This one tackles the stateless nature of the web. Before this, every time an agent spun up to, say, check inventory on a vendor portal, it was a brand new session.
So it had to go to the login page, type the password, do the two-factor authentication, accept the cookies every single time.
Which is slow, sure, but it also triggers fraud detection systems, right? If you log in from a new device 5,000 times a day,
your account is getting banned immediately.
Exactly. So this update introduces browser profiles. It lets the agent infrastructure save and reuse cookies and local storage. The agent logs in once, saves that state, and the next run just injects that profile.
It's resuming the session instead of restarting it.
Yep. AWS says it cuts setup time from minutes down to tens of seconds. But the bigger win is parallelization. You can have multiple agent threads sharing that one authenticated profile.
So I could have 50 agents scraping a site all at once using just one valid login.
As long as you don't violate the website's own rules, yes. It turns a fragile script into a scalable workforce.
Okay, but what about security? If these agents are running code, where is that happening? On February 2nd, there was an update about server-side tools.
This is all about the security boundary. In the old model, the LLM would generate a command like query the database and send it back to the client app.
Meaning the client app needed the database password.
Right. You were potentially leaking secrets all the way out to the end user's device. With server-side tools, the execution stays inside AWS. Bedrock orchestrates the tool call within your secure VPC and just sends the final answer back.
The credentials never leave the data center. But doesn't that add a hop, add latency?
You'd think so, but it often reduces it. The tool execution is happening right next to the model, not making a round trip to a laptop somewhere on the other side of the world.
And speaking of efficiency, they also added a new prompt caching TTL, or time to live.
A 1-hour TTL. This is for those long-running agent tasks. Imagine an agent working for 45 minutes on a single problem. The core context, that initial prompt, doesn't really change.
So instead of reprocessing it every single turn,
you cache it for an hour, it dramatically cuts your token costs for these complex multi-step workflows.
it really feels like they're just giving AI developers the same tools regular software engineers have had for years: caching, state management.
And infrastructure as code.
Yeah.
That was the other big one. AgentCore now supports CloudFormation, CDK, and Terraform.
So I can stop building my agents by clicking around in the AWS console.
You really shouldn't be doing that for production anyway. Now you can define your agent, its tools, its prompts, everything in a template file. You can check it into Git.
You can do a git revert on your AI agent if a new prompt goes wrong.
That's the whole point. It's essential for building anything serious. You get versioning and rollbacks.
Okay, shifting gears. Infrastructure. For anyone dealing with GDPR or strict data sovereignty rules, the big news has to be the AWS European Sovereign Cloud.
This launched in early February. First region is in Brandenburg, Germany. And I want to be really clear here. This is not just another region like U-Central 1. This is a physically and logically separate cloud.
The press release mentioned a specific partition name, AUSUSC. What does that actually mean?
That detail is critical. In AWS, a partition is the highest level of isolation. The US government has its own partition, China has its own, now Europe has one. It means the user identities, the billing, the controls, it's all separate.
And the people running it.
That's the absolute key. All operations are controlled by EU residents, EU citizens. It's designed to create an air gap against things like the US Cloud Act.
But usually these sovereign clouds are years behind on features.
That's what's so interesting. They launched with Amazon Bedrock and SageMaker available on day one. It's a massive 7.8 billion euro investment to make sure EU customers can run Gen AI workloads without any compromise.
And quickly, before the case studies, the hardware. G7E instances.
Right. These are powered by NVIDIA's Blackwell GPUs, the RTX PRO 6000. The headline metric is up to 2.3 times higher inference performance.
And inference cost is always the killer at scale, so that goes straight to the bottom line.
Correct. It makes running these huge models, like the Claude Opus 4.6 we started with, actually affordable.
Speaking of affordable, let's talk about who is using this. 3 case studies this week: BGL, Clarus Care, and Associa. Let's start with BGL and financial services.
This is my favorite one because of how they structured it. BGL deals with retirement fund compliance. They used the Claude Agent SDK, but they didn't just dump a bunch of PDFs into a database.
They use these skill.md files.
Yes. They treated their domain knowledge like code. They made markdown files that explicitly define the rules for tax law and other files for project context. It's like prompt engineering as code.
That's a great phrase for it.
And they paired this with a tool called DBT. The key here is that BGL's agent doesn't actually try to do the math itself because we know LLMs are bad at math.
So what does it do? Just write the SQL query.
It acts as a semantic translator. A user asks a question in plain English, the agent turns that into a SQL query, and then hands it off to their trusted, verified DBT platform to actually run the numbers.
So the AI handles the messy human language, and the database handles the precise math.
That is the winning architecture right now. The AI is a component, a translator, not the whole system.
Okay, next up, Clarus Care. Healthcare, patient calls. Their big metric was speed.
Extreme speed. They were targeting a back-end latency of under 3 seconds. For a voice AI that has to listen, think, and speak, that is an incredibly tight window.
How do you do that and still sound empathetic?
Orchestration. They didn't just use one big model. They used a mix of Claude 3.5 Sonnet for the complex stuff and smaller, faster Amazon Nova models for simple tasks like intent detection.
So they're routing traffic. Easy questions go to the fast model, hard questions go to the smart one.
Dynamic routing. It's the only way to balance cost, speed, and quality in a real-time voice system. And they hit 99.99% availability, which is table stakes in healthcare.
And finally, Associa. They manage homeowners associations. A huge volume of documents.
Millions of them. Bylaws, minutes, invoices. They use the GenAI Intelligent Document Processing Accelerator.
The metric that jumped out here was the cost. 0.55 cents per document. Half a penny.
And that cost saving came from a really smart, almost low-tech decision. They realized that for most document classification, you don't need to read all 50 pages.
You just need the first page.
We just need the first page.
Yeah.
So they built a pipeline that just OCRs page 1 and sends only that text to an Amazon Nova Pro model. Their accuracy went up to 95% because they cut out all the noise and their token costs just plummeted.
It's a lesson in restraint. Just because the model can read 1 million tokens,
doesn't mean you should pay for it to read 1 million tokens. Associa proved that knowing your domain is more important than just throwing more compute at a problem.
So if you look at BGL coding their prompts in Markdown, Associa cropping PDFs, AWS caching schemas, the real theme here is just efficiency.
It's just good engineering. We're finally seeing the rigorous practices of software development, version control, caching, optimization being applied to AI development.
It's growing up. I want to go back to that BGL example for a final thought. We spent the last 2 years worried about autonomous AI agents taking over. But BGL's system is explicitly designed so the AI can't do the logic. It can only write the request for the logic.
It connects right back to the structured outputs feature we started with. The industry is learning that the real value of these models isn't in total autonomy. It's in their ability to follow very specific instructions inside a very tight box.
We're building padded cells for them.
We are, and inside those cells, they're incredibly useful.
So the future isn't some super intelligent AI god running the company.
No.
It's a very fast, very obedient translator that speaks perfect JSON.
And honestly, that's a much more useful employee to have.
That's our deep dive for this week. We'll be keeping a close eye on that sovereign cloud rollout in the coming months. Thanks for listening.